So, till now we have discussed that there are three equations of motion: v is equal to u plus at and v square is equal to u square plus 2as and s is equal to ut plus half at square. And all these three equations can be used to calculate many unknown terms regarding the particle moving in a straight line with uniform acceleration. Okay. Along with that, there is an additional formula, that is v is equal to x by t. This is used only for uniform velocity. Remember, this is not to be used for uniform acceleration. Uniform velocity. This is for uniform acceleration. This is for, these three are for uniform acceleration, that is only for uniform velocity. There is another formula for average velocity too, because that is total distance by total time taken. We have already seen that. And these three equations we always use. Suppose a body is moving in a straight line with initial velocity u. After some time, its velocity changes by v. In the meanwhile, it has traveled a displacement s. This is the situation where velocity increases. V is greater than v. V is greater than v. Then we use these equations. Suppose there is a case in which the velocity of a particle is very high in the beginning. Later it decreases in a time t, making a displacement s. That is also another position where v is less than u. Means final velocity is less than initial velocity. It is like braking of a vehicle. So when vehicle is moving, it is moving with high velocity. When brakes are applied with high velocity to low velocity, the particle will come to lower velocities, where v final velocity is less than initial velocity. In such cases, we have seen that acceleration is negative, and here in such cases acceleration is positive, where velocity is increasing. Here velocity is increasing, that's why wherever a is coming, wherever this a is coming, accelerations are positive. In such cases where acceleration is negative, the equations of motion will become v is equal to u minus at. Instead of u plus at, it becomes u minus at, and v square is equal to u square minus 2as. It becomes, okay? V square is equal to u square minus 2as, because wherever a comes, negative becomes. S is equal to ut minus half at square. Ut plus half at square becomes ut minus half at square. Okay, these are the adjustments we must know. Okay. Now let's go to certain practical conditions. Pretty practical conditions. What are those practical conditions? The practical conditions are like, where do you find uniform acceleration motion in a straight line? If a car is moving with initial velocity u along a straight road, after some time t, its velocity changes, having an acceleration. Then this is the example for this kinematic equations of motion. You can apply these equations for this motion of the car. Okay. There is another very simple situation, that is motion under gravity. Motion under gravity. No motion in gravity. Whatever. Motion in gravity means if you are standing on ground and if you throw a stone vertically up, see, vertically up is different. If you throw a stone here from this point, it will not go in a straight line. It will follow a parabolic path generally, no? It will not move in a straight line. It moves in a parabolic path which covers x-axis and y-axis also. To a certain height it goes, and to a horizontal distance also it moves. I am not asking about this case. No, we are not asking about this. We are not talking about this. We are talking about a thing where you have thrown a a stone, you have thrown a ball or whatever something in vertically upward direction. The stone initially moves with very high velocity because while throwing you will be throwing with higher speed. Because of Earth's gravity, because of Earth's gravitational force, the body will lose its velocity slowly. It reaches a particular height where its final velocity will be zero because it stops there and comes back. Starts coming back. I will write another adjacent line from this. Don't think that it is coming back to a different position. It will coming back to his own hand. It will be coming back to its own hand. Now from v is equal to 0, it starts increasing the speed, and later when it reaches the hand, it will regain the original speed. Means if a boy throws a stone with u is equal to 25 meters per second, the stone goes upwards. Stone becomes velocity 0. Stone stops there in the air, and later stone comes back, hitting the hand of the boy with the same 25. Now how the situation occurs? 25 becomes 20, 20 becomes 15, 15 becomes 10, 10 becomes 0. This is how the velocity changes. Suppose now velocity is 0, it becomes 10, it becomes 15, increases, it becomes 20, it becomes 25 at the hands. While going, it becomes decreasing, it goes on decreasing. While coming back, it comes back, increasing its speed, and when it reaches the hand, its velocity will be 25 meters per second only. Okay. And this is one of the classical examples for motion in a straight line with uniform acceleration, because the gravitational force due to Earth gives you a uniform acceleration called g, which is called acceleration due to gravity. Acceleration due to gravity means in all these three equations you already know the A, because you are moving, the body particle is moving in the gravitational acceleration. It cannot have any other random value like the acceleration of a car. Acceleration of a bike are arbitrary. It can have any value. It can be 1 meter per second square, it can be 10 meter per second square. It all depends on your speed and your capacity. But a stone or a wall or a ball or a wooden object or a glass object or anything, if you throw into space, it will always be falling down, it will always be coming up with the same acceleration, which is nothing but 9.8 meter per second square. Means you approximately take it as 10 meter per second square, because 9.8 is very close to 10. Means if you throw a stone with 100 meter per second speed, within 1 second, its speed will become 90 meter per second in 1 second. Loses 10 in 1 second. Loses 10 meter per second in 1 second. In 1 second time, its velocity becomes 80 meter per second. In 1 second, its velocity will become 70 meter per second. So on it goes. And it goes to a certain height when its velocity will be 0 at a certain height. Afterwards, when it starts coming back, its velocity is 0. It becomes 10 meter per second in 1 second. Its velocity will become 20 meter per second in 1 second. Its velocity will become 30 meter per second in 1 second. See, velocity is increasing at the same rate of 10. Velocity is increasing at the same rate of 10 meter per second per second. Velocity is lost, is decreasing at the rate of 10 meter per second per second. That's why the acceleration due to gravity while the body is moving upwards or downwards is same. It is 9.8 meter per second square. While going up, it becomes minus 9.8 or minus 10 while going up, because negative acceleration. While coming down, the velocity is increasing. That's why it becomes positive acceleration, which is plus 9.8 meter per second square or plus 10 meter per second square. Okay, but for neat and fast calculations, use 10 meter per second square unless mentioned, because in the question itself they will they will tell you take 9.8 as 10 itself. If they tell you like that, then only use 9.8 as 10. Otherwise, don't do that. Just use 9.8 only, because some questions are based upon 9.8 only specifically. Okay. Right. So for Earth's gravitational motion, for the motion under gravity, how these equations will be changed? Very simple change. V is equal to U plus GT for a body moving down, because acceleration is positive. V square is equal to U square plus 2G H I will write, because S is the displacement, right? S is the displacement when the body is moving down. S is the displacement, but here we will not call this as the displacement, we call this as height, right? Height H. 2Gs will be written as 2Gh. Displacement is Hd, and S means H is equal to Ut plus half Gt square. Ut plus half Gt square for downward motion. What is the equation for upward motion? If you are throwing the object upwards, then V is equal to U minus GT, right? Very simple, because G becomes negative. So V square is equal to U square minus 2GH, because G is negative, and H is equal to Ut minus half GT square, because G is negative. So these three are the common equations for motion under gravitation. Okay. Yes. After this, we will see some of the shortcut formula to calculate some of the terms associated. Suppose you are throwing an object with initial velocity u. It goes to a height h. There this velocity becomes 0, and we take time t as the time required to go upwards. I call it as t1. T1 is the time taken to go upward, which is called time of ascent. TA. Better write as TA. And the body comes back with V is equal to 0 to V dash is equal to U. From V is equal to 0, increases the speed. While coming back, it will become V dash. That V dash is nothing but U itself. Then time taken for this is called descent time. Time of descent, TD. If this velocity is same, coming back velocity is also same, then time of ascent is equal to time of descent. It is a well understood fact. You can check it out also. You can check it, no problem. I will show you. Okay, time of ascent is equal to time of descent. Means if it takes 2 seconds to go up to the height, then it will take 2 seconds to come down to the same height. Time of ascent is equal to time of descent. So now let's calculate. How do you calculate it? T, V is equal to U plus G, TA. U plus G, TA. What is TA? Time taken to go upwards. What happens to the final velocity at the greatest height, at the maximum height? 0 is equal to U plus GT. Right? But since it is going upward, I should not write plus, I should write minus. U minus GT. Then U is equal to GTA, or TA is equal to U by G. This is what you have obtained. Time of ascent is equal to U by G. Very simple formula. Just know with what speed you are throwing. The speed with which you are throwing and the value of acceleration, if you divide, you will get the time of ascent. For the time of descent, we will use the same equation. you will use this equation. V dash is equal to V plus GTD, right? Because V dash is what? The velocity obtained after a time TD when it reaches the ground. Ground means when it touches the ground, its velocity becomes 0. You should write it as 0. No. While hitting the stone, while hitting the hand, with what velocity it hits the hand, that is the velocity with which it falls to the ground. Okay. If there were no ground, it would have moved continuously. So V dash is equal to V plus GD, because it is coming down, velocity is positive, the acceleration is positive. Okay. V is the initial velocity, which is 0, plus GTD is equal to, what is V dash here? V dash is U itself, we know it. That's why U is equal to GTD. It means TD is equal to U by G. Again, you have got the same type of ascent and time of descent are same, right? Yes. And also you can prove, if VA is equal to TD, you can also prove that the velocity of throwing is equal to velocity of reaching. Both are same. Let's have the equation for calculation of the height of the throwing. Means to what height the object goes when I throw it with certain velocity u. Further, what I will use? I will use the second equation, that is h is equal to ut plus minus half gt square, because h is the height obtained, t is the time taken, and g is the acceleration. If you know the time of ascent, you can calculate the h. So let's put h here. What is time of ascent here? Time of ascent, do you know what is the time of ascent? If you know the time of ascent, u into u by g is minus half into g into what is t square, that is u square by u by g whole square, right? So now it becomes u square by g minus u square by g only. U square by 2. Okay, because half is there. U square by g square into g cancelled, so u square by 2g. Now u square by g, we will take it outside. U square by g is a common thing. Now it becomes 1 minus 1 by 2. What is the value of 1 minus 1 by 2? 1 minus half is half itself. That's why it becomes u square by 2g. Means h is equal to u square by 2g is the equation to calculate maximum height. You can use another method also. Consider this equation. V square is equal to u square minus 2gh, right? This is the equation we use when we don't know the time. You don't know the time. How do you use this? You know that at the maximum height, final velocity will be 0, right? At the maximum height, while reaching the height, what will be the velocity of the particle when you throw it vertically upwards? Vertically upwards is very important. Vertically upwards means it's going in a straight line. Okay? When you throw it vertically upwards, the final velocity is 0. U is, you don't know, minus 2gh. U square is equal to 2gh, or h is equal to u square by 2g. You have got the same thing very simply. You did not go through this all this equation. You simply h is equal to u square by 2g. So we have obtained 3 equations. One is to calculate time of ascent. One is to calculate time of descent. Another one is to calculate the maximum height obtained. What is the time taken to go to the height, coming back to the same position? Total time of flight will say. Time of flight. If you want to calculate the time of flight, then that is capital T. We will take it as capital T. That is 2 times TA. Alva. Because hoga ke 4 second. Barak 4 second. 2 times 4 second. So it is always been 2 times 1 of the time. Means TDTA ಏನು ಬೇಕಾದರೂ ಬರೆಯಿರಿ. ಅದನ್ನ 2T ಅಂತ ಬರೆಯಿರಿ. 2TA ಅಂತ ಬರೆಯಿರಿ. 2U by G ಆಗುತ್ತೆ. 2U by G means going takes TA, coming back also takes TA. That's why it becomes 2TA. 2U by G. So these 3 are the most important fundamental equations used to calculate the different aspects of motion in a straight line. you do remember these equations, and we will solve many of the questions using these equations. Okay? Yes. So good morning. Let's start. Motion in a straight line. Last part of this. In this class, we will discuss one remaining shortcut and one remaining very important formula of acceleration, on acceleration. And we will discuss the concept of relative velocity. Before that, we will summarize what we have understood so far. So far, what we have understood is motion in a straight line involves sometimes uniform velocity. Motion in a straight line involves sometimes uniform acceleration too. When the journey starts from an initial velocity, ends with the final velocity. In the meanwhile, there is a time t elapsed, and x is the displacement, or sometimes we call s is the displacement in time t. So this is what we have understood. And to explain motion in a straight line with uniform acceleration, for this, the case is very simple. V is equal to x by t is the only equation possible for this. X by t or s by t, whatever. That is the only equation for uniform velocity. But for uniform acceleration, we have three sets of set of three equations. One is v is equal to u plus at, v square is equal to u square plus 2as, and s is equal to ut plus half at square. So these three equations we have discussed, and wherever acceleration is positive, the positive sign will come in the equations, and if you are using with negative acceleration, if the body is slowing down with a retardation, then we use negative acceleration, where the equations will change to minus ut minus half at square. Right? So what is the typical example for motion in a straight line? For motion in a straight line, the typical example is the motion under gravity, motion under gravitational field. That is, the things fall, even if it may be a big rock or it may be a big small stone, all of them fall towards earth with the same acceleration. Even though a big rock will fall towards earth with the same acceleration, a small stone will also fall towards earth with the same acceleration. That acceleration is 9.8 meter per second square. Approximately, in some calculations, we will take it as 10 meter per second square. And according to this equation, according to this acceleration, we will modify this equation with v is equal to u plus gt. V square is equal to u square plus 2g h it becomes, because in the case of gravity, either it is displacement vertical or displacement above vertical. Okay, so it is referred as height. The displacement in horizontal direction is displacement. Okay, fine. That is represented by s or x or d, whatever it is. But vertical motion is generally referred as, vertical displacement is generally referred as height. That's why we will write in the place of s h 2g h ut plus half gt square for the body falling downwards. For the body rising upwards, we will have v is equal to u minus gt, v square is equal to u square minus 2gh ut minus half gt square.